So another approach, and the final approach I'm going to show you, is what's referred to as the lactate minimum. And the lactate minimum was proposed by Tegba in 1993. And the lactate minimum also proposes to be able to overcome the issues of visual inspection, overcome the issues related to fixed concentrations, and also potentially the issues that we saw with the IAT in terms of those controls of how the lactate is recorded, particularly in the recovery period. So this is from a fairly recent paper which kind of gives a little bit of an overview. And you'll notice how different this is to what we've been talking about. This test begins with high intensity efforts, that's completely different, to induce a hyperlactemia state, which they call phase 1, followed by 8 minutes of passive rest, phase 2, and finally an incremental test initiated with low exercise intensity but high blood lactate concentration, phase 3. During the first incremental stages, the blood lactate concentration is expected to fall into a minimum point and rise again over the following stages. So it's complete antithesis to what we've been thinking about. Where we've been thinking about doing low intensity exercise and progressively increasing that low intensity exercise and dragging the person through that kind of steady state to non-steady state work, this is proposing the alternate, which is actually we're going to start with non-steady state work, induce a hyperlactemic response, and then look at what happens when they get a clearance of the lactate during exercise. So it's quite a clever idea. And they go on to write this. This minimum point, named the lactate minimum, provides an estimation of the intensity that represents the balance between the appearance and clearance of arterial blood lactate. So in other words, fundamentally they're arguing, and the authors are arguing, it does everything that we would think about in terms of what Brooks is talking about. Rates of appearance and disappearance of lactate. Everything that we want to do in terms of identifying the LT2 response. So there's nothing new. We know that this is the response that we're looking for. It's just another way of trying to identify this point where the rate of appearance of lactate will start to exceed the rate of disappearance of that lactate. And so this is what you end up with. So what we've done here, this is what in those quotes is the phase 3 response. So what the participants will have done is they will have done some incredibly high intensity work prior to doing this test. And the high intensity work is something like the equivalent of doing 2 Wingate tests, 2 consecutive Wingate tests, or getting an athlete to run a 300 meters on a track flat out with a short recovery of probably less than 30 seconds to less than 30 seconds, and then a 200 meters. So you might do 2 Wingates separated by 1 minute, maximal efforts. So they are going to produce a hyperlactemic state, really high lactate concentrations. So there's a significant amount of lactate being produced, not an awful lot of lactate being cleared. Then they would do this passive protocol, which is a 7 to 8 minute protocol. Now, in our laboratory, when we've done this, we've actually had the participants walking because it was just not comfortable sitting there with all that lactate sitting in the legs. So we had them do some walking. Then they start the incremental test, and notice it is a conventional incremental test. So they're starting at low velocities and increasing the velocity as one would anticipate we would normally do. But now we record the blood lactate concentration. We don't bother with the lactate really in that phase 1 or phase 2 response. But notice what's happening now. The lactate is starting to clear. In other words, the lactate concentration is falling. Why is it falling? Because you've got those inactive slow twitch fibers. The slow twitch fibers, according to the model, would not really have been actively engaged during those Wingate tests or those high intensity efforts. The fibers that would have been engaged are the less efficient but more power producing fast twitch fibers. So the net result is that we get lactate clearance. So the lactate concentration starts to fall. But then, as one would predict from the notion of the lactate model, the idea of consumption and production of lactate that we've been referring to from Brooks, there comes a point where we haven't got inactive muscle fibers. We have got fibers that really are still really perhaps quite fatigued, our fast twitch fibers, and so we get to the point where the rate of production starts to exceed the rate of consumption. So you get to this U point here, and so the nadir of this curve here relates to what they call lactate minimum, which is meant to be what we call the lactate turn point. It's meant to be the same point. So it's just an alternate way of referring to this response. It's a very, very neat idea, and it's received an awful lot of attention in the literature. People like Helen Carter spent a long time kind of interrogating this as a method. And this is where you start to see it falls apart. So if you change what happens in the hyperlactemic inducing exercise, so the phase 1 exercise, you change the outcome in the incremental test. So here we've got 4 different approaches that have been used, and then the subsequent responses in the blood lactate exercise intensity profile. And you can see there is quite a significant shift. So if you take just this response here, here's the nadir of its curve. So we're coming in at about this point here. But if I take the nadir of this curve, it's coming in here. So there is quite a difference in terms of what we are predicting. And if I take this curve here, it's probably the nadir is here. So it's perhaps more closely aligned with this one, but certainly different to this one. So what you do in that initial phase 1 has quite significant ramifications in terms of what is happening. But the main thing is it's made an awfully big assumption, which is that slow twitch fibres wouldn't have been engaged in that maximal exercise bout, and clearly they would be engaged. You know, despite the fact that it's predominantly fast twitch fibre recruitment, we don't just recruit fast twitch fibres, because as we start to slow down in a Wingate test, anybody who's ever done a Wingate test will recognise this. You can't maintain the power output. So what happens is you get a power decline. As the power declines, we do that because we've got a fatigue-like response in the fast twitch fibres. There'll be some slow twitch fibre recruitment trying to engage, because it starts to become certainly a little bit more aerobic in terms of the nature of the test. So they'll be engaged. So you haven't got this physiological state that the authors are purporting to see. So unfortunately, the lactate minimum really doesn't do what we want it to do. Its test-retest reliability isn't particularly strong either, and it certainly also seems to be affected by things like carbohydrate consumption, which changes the outcome of the test.